Hello, Advanced Algebra students. I hope you are having a fantastic day. I'm looking forward to seeing you in our Zoom session tomorrow, but I wanted to give you the notes for lesson 1.4. So this lesson is on literal equations and formulas, and I have to be honest with you, some students don't really like the lesson that much. It's a little disconcerting to them because you're working with equations, but typically you don't get, say, x equals 2 for an answer. What you're doing in the case of literal equations is you're taking an equation that is generally mainly letters and rearranging the letters just in a different way. So I'll do several examples of this, but again, if you feel a little bit of frustration, just know that that's normal and that we will have plenty of time to go over this in class tomorrow in our Zoom session. So let me first just read you what a literal equation is. A literal equation is an equation which consists primarily of letters. Formulas are an example of literal equations. Each variable in the equation literally represents an important part of the whole relationship. Okay, so let's do an example here. If we have the formula I equals PRT, so let's do this for example 1. I equals PRT. It's a simple interest formula that calculates interest based on principal, that would be the P, interest rate, which is the R, and time, which is the T. Janet wants to calculate the time it takes to earn a certain amount of interest on a principal amount in an investment with simple interest. How can she rewrite the equation to help find the answer to her question? So currently this formula is written in terms of interest. Interest equals principal times rate times time. But if we want to rearrange these letters so that they are written in terms of time, we need to isolate time. So what we have to do in general is ask ourselves what is happening next to the variable that we want to isolate and do the opposite of what we see. So currently we can see that time is being multiplied by P and R. So what would be the opposite of multiplying by PR? The opposite of multiplying by PR would be dividing by PR. So I want to do whatever I do to one side, I do to the other. When I do that, on the right, the P and the R cancel, and my remaining equation is that time is equal to interest divided by principal times rate, or PR. So all we've done here is rearrange the formatting of our formula. So that was the first part. How do you rewrite the equation? The second part of this question says, how long, that's the time, how long would it take Janet to earn $100 in interest on a $5,000 investment with a simple interest of 3? So now that we have rearranged the equation, we can put in the information that we've been given. We want to earn $100 in interest, so we will put that in for I. The principal is $5,000, so we'll write $5,000 first in our denominator. And the interest rate is 3%, so we're going to put that in as 0.03. When we simplify that, we get that T equals 100 over 150, or 2/3. So it would take Janet 2/3 of a year, which would be 8 months, to earn the $100 of interest that she wants to earn. So, some students might say, well, why bother? Why do you rewrite literal equations when you're solving problems? One of the reasons that we do this in math is because once you've rewritten a formula to isolate a different variable, you can reuse that formula again in a different problem. So let's say that Janet wanted to figure out how long it would take her to earn $200 in interest. She can use the same formula that she already reconfigured. So that would be example 1. All right, let's do another example, example number 2. And again, our 2 basic steps are 1, to rewrite the formula, and then after we have done that, to plug in the numbers that we want to use. So this is example 2, and again, all you have to write down is what I put on the board. But the example reads, according to Teo's bread recipe, he should bake the bread at 190 degrees Celsius for 30 minutes. His oven measures temperature in Fahrenheit. How can he use the following formula to determine which temperature he should set his oven to? Okay, so his formula that he has is Celsius is equal to 5/9 times the quantity F minus 32. So our first step, again, is to use opposite operations until the variable you want to solve for is on its own. We currently have temperature written in terms of Celsius, but we want to rewrite it in terms of Fahrenheit. So we're going to use one of the skills that we talked about in our last lesson. Does anybody remember what did I say is the most efficient way to get rid of a fraction in an equation when you just have one fraction? Does anybody remember what that tip was? How do you remove a fraction from an equation when you just have one fraction in the equation? The method we talked about was multiplying by the reciprocal. So I'm going to take both sides and multiply by 9/5. The awesome thing about doing that is that on the right, the 9's and the 5's cancel. And now I have 9/5 times Celsius equals F minus 32. So we have now gotten rid of that first fraction, and now we want to use opposite operations. The opposite of subtracting 32 is adding 32. So I'm going to have 9/5 C plus 32 equals F, or if we want to put the F first, F equals 9/5 C plus 32. So now we have rewritten our temperature equation in terms of Fahrenheit. Now, he wants to know, Teo wants to know, how he can determine what temperature he should set his oven to. So we're going to use the formula that we just got. F equals 9/5 C plus 32. And we're going to plug in the information that we have. The recipe called for the bread to be baked at 190 degrees. And so what we need to do is put 190 into the formula. So we're going to do 9/5 times 190 plus 32. Now, I believe I've brought up cross-canceling before. This is a skill that you want to become more and more comfortable with. Technically, if we wanted, we could take 9 times 190 and divide by 5, but it will be much more efficient to cross-cancel here first, because 5 goes into 190 38 times. So I'm going to cross-cancel and write a 38 here. If you're at all uncomfortable about this, be sure to ask me during Zoom and I will be delighted to help you. When we take 9 times 38, we get 342, and then we would add 32 to that and get 374 degrees. So Teo will need to cook his bread at 374 degrees Fahrenheit. Okay, so those were 2 examples so far. I do want to do 2 more examples with you again to try to give you help with questions that might be similar to what you would see on your homework. So one thing that sometimes comes up is when you're working with a formula that is essentially a fraction equals a fraction. So for example, V equals 3K over T. I believe this has to do with velocity and time. So in any case, we can think of the V as being over a 1. Now, you don't have to do it this way, but for me personally, this is considered to be a proportion because we have a fraction equal to a fraction. When I'm working with proportions, my preference is to solve them using something called cross multiplication. So if I wanted to solve this for T, I could simply cross multiply. So along this diagonal here, I would have T times V equals 3K. And then to isolate the T, I would say, what is the opposite of multiplying by V? Well, that would be dividing by V. and then I'm going to get T equals 3K over B. So that was example number 3. Okay, I've got one more example for you guys, and then we will be done with the notes, and I'll look forward to seeing you during Zoom. So example number 4, on this problem it says, solve for y. Then find the value of y for the given value of x. Now I want to make sure that you know to do this on the homework. So when the problem tells you to solve for a variable and then plug in a number after that, I don't want to see on your homework that you just plugged in the number. I do want to see that you did the hardest part of the problem, and that is solving for the variable indicated. So let's go ahead and look again at example 4. If our problem is 7x minus xy equals negative 18, and then they want us to solve when x equals negative 4. Now keep in mind, as I said, there are 2 major steps here. The first one is to solve this formula for y, so we're not worried about x yet. When we solve for y, again, we want to use our opposite operations, looking at what's happening next to y. I can see that I have a positive 7x here, so I am going to subtract 7x from both sides. And I would have negative xy equals negative 7x minus 18. Now I still don't have y on its own, so I look at what's happening next to y. Y is being multiplied by negative x. So the opposite of being multiplied by negative x would be dividing by negative x. When I do that, this cancels out here, and I have y equals negative 7x minus 18 over negative x. Now, because these are all minus signs, if I want, I can multiply the top and bottom by negative 1 and turn these into positives. That would not change anything. It's not necessary. Make sure that you understand this is the final answer to this problem. If you really wanted to, you could rewrite this as y equals 7 plus 18 over x, because 7x divided by x is just 7, but you can't just cross out these x's and leave 7 plus 18 as your answer. So these x's cannot be cross-canceled here because of this plus sign. So either one of these choices would be a legitimate answer to the question. Personally, I would stop here just because it's less work. So that was part 1 of this example. For part 2, they want you to calculate what is y when x is negative 4. So let's rewrite this formula up here. I know that y is 7x plus 18 over x. So when I plug in 4, I get negative 4. I get 7 times negative 4 plus 18 over negative 4. 7 times negative 4 is negative 28 plus 18 over negative 4. Negative 28 plus 18 would be, negative 10 over negative 4, and that ends up being 5/2. So there are 2 parts to the answer to this question. One is, how do you rewrite the formula so you're isolating a different variable? And then the second part of the question is, after you've done that and plug in x, what do you get for a number answer? So anyway, those were pretty thorough notes on 1.4. Every type of example that you need to see for the homework should pretty much be in there. But if you have any questions, we'll talk about it during Zoom. Thanks, you guys. All right, bye.